Assalamualaikum and hi everyone. In this video, our group will be presenting about the group project waiting line. So, let's check out. Question 1. The new Kuasa Fishing Marina is to be located on the Endau River near Rompin. Assume that Kuasa decides to build a docking facility where one boat at a time can stop for gas and servicing. Assume that arrival follow a Poisson probability distribution with an arrival rate of 5 boats per hour and that service time follow an exponential probability distribution with a service rate of 10 boats per hour. Answer the questions. It is given from the question, arrival rate lambda is 5 boat per hour and service rate mu is 10 boat per hour. For A, what is the probability that no boat are in the system? Since it mentioned in the question that only one boat at a time, so we have to use the formula P0 in single channel queuing model. So P0 equal to 1 minus rho, which 1 minus lambda over mu, and we get the answer is 0.5. For B, what is the average number of boats that will be waiting for service? The keyword here is average number and waiting. That's mean in queuing. So we have to use formula LQ equal to lambda square over mu multiply mu minus lambda. Key in the value and we got the answer 0.5 boat. For C, what is the average time a boat will spend waiting for service? The keyword is average time and waiting for service. So we have to use the formula WQ equal to lambda over mu multiply mu minus lambda. And we get 0.1 hour as the answer. For D, what is the average time a boat will spend at the dock? Same like in question C, but the difference is at the dock referred to system. So we use the formula W equal to 1 over mu minus lambda. So 1 over 10 minus 5 equal to 0.2 hour. Question E. If you were the manager of Kuasa Fishing Marina, will you be satisfied with the service level your system will be providing? Why or why not? If I were the manager of Kuasa Fishing Marina, I will be satisfied with the service level my system will be providing because 50-50 chance that either the system will be busy indicating the boats will have to wait in line or the system will be idle. In addition, about 0.5 boats that has to wait in line would only have to wait for about 6 minutes in average. Furthermore, each boat will spend roughly about 12 minutes in total at the dock, which shows that each service will not take too much time. Next sub-question. The manager of the Kuasa Fishing Marina wants to investigate the possibility of enlarging the docking facility so that 2 boats can stop for gas and servicing simultaneously. Assume that the arrival rate is 5 boats per hour and the service rate for each channel is 10 boats per hour. Question F. What is the probability that the boat dock will be idle? Since the number of servers is 2, which more than 1, so we have to use the formula multi-channel queuing model. Use formula P0 and find the rho value. Then we get the answer 0.6 as the probability. For question G, what is the average number of boats that will waiting for the service? The keyword is average number and waiting for service, which means waiting for the queue. So, we need to use the formula LQ in multi-channel. Key in the value and calculate. Finally, we got the 0.0333 boat as the answer. For question H, what is the average time a boat will spend waiting for service? This question same like question G in the queue. We have to find average time. So, use the WQ equal to LQ divide lambda, 0.0333 divide 5. We got the answer 0.0067 hour. For question I, what is the average time a boat will spend at the dock? At the docks mean in the system. So, we need to find the W equal to L over lambda. Before that, we have to find L value first. Calculate all the terms and we get 0.1067 hour for the answer.
Next is question 1J. Comment on the service level that Kuasa will be providing with 2 docks. The probability the dock will be idle with 2 docks is 0.6, which is higher than 1 dock, which is 0.5. The average number of boats that will be waiting for service with 1 dock is 0.5 boats, meanwhile 2 docks is 0.0333 boats. The average time A boat will spend waiting for service with 2 dogs is lower than 1 dog. A boat will spend 0.0067 hours for service with 2 dogs and 0.1 hours with 1 dog. Plus, the average time a boat will spend in the system with 2 dogs is lower than 1 dog, which is 0.1067 hours, and the average time with 1 dog is 0.2 hours. Thus, this shows that the service level that Kuasa will be providing with 2 dogs is better than 1 dog. Question 2. Okala Software System operates a technical support center for its software customers. If customers have installation or use problem with Okala software products, they may telephone the technical support center and obtain free consultation. Currently, Okala operates its support center with 1 consultant. If the consultant is busy when a new customer calls arrive, the customer hears a recorded message stating that all consultants are currently busy with other customers. The customer is then asked to hold and is told that a consultant will provide assistance as soon as possible. The customer calls follow a Poisson probability distribution with an arrival rate of 5 calls per hour. On average, it takes 7.5 minutes for a consultant to answer a customer's question. The service time follows an exponential probability distribution. So A, what is the probability that no customer in the system and the consultant is either? The arrival rate is equal to 5 calls per hour and the service rate is equal to 8 calls per hour. The formula used is PO equal to 1 minus rho and it resulted us to gain the probability is equal to 0.375. B, what is the average number of customers waiting for a consultant? For this question, the formula used is LQ equal to lambda squared over mu multiplied by mu minus lambda. After substituting, we get the average number of customers waiting for a consultant is equal to 1.0417 customers. For C, what is the average time a customer waits for a consultant? To solve this problem, we use the formula W2 equal to lambda over mu multiplied by mu minus lambda. We get the average time a customer waits for a consultant is 5 over 34 hours or 0.2083 hours.
Moving on to question D. What is the probability that a customer will have to wait for a consultant? We're using the formula of rho. The answer is 0.6.25 in percentage is 62.5%. E. Okala's customer service department recently received several letters from customers complaining about the difficulty in obtaining technical support. If Okala's customer service guidelines state that not more than 35% of all customers should have to wait for technical support and that the average waiting time should be 2 minutes or less, does your waiting line analysis indicate the Okala's or not meeting its customer service guideline? What action, if any, would you recommend? My answer is that since Okala's customer service department current percentage that the server will be busy is at 62.5% and the current average waiting time is 0.2083 hours. This shows the both are higher than their customer service guideline, which means Okala's does not meet its customer service guideline. Therefore, I would recommend to increase their service rate to 15 calls per hour. By increasing the service rate, the percentage that customers should have to wait for technical support will drop to 33%. The increment in service rate will also reduce its average waiting line to 2 minutes. Thus, Okala's will eventually meet its customer service guideline. In F, to improve customer service, Okala's software system wants to investigate the effect of using a second consultant at its technical support center. What effect would the additional consultant have on customer service? The two technical consultants enable Okala to meet its service guideline, not more than 35 customers having to wait for technical support, and an average customer waiting line of 2 minutes or less. Discuss. Step number 1. We have to find the probability that an arriving customer have to wait for service, which is rho equal to 0.3125. In percentage will be 31.25%. The second step is that we need to find the probability there is no customer in a system, which is P null. The answer will be 0.5328. Third step is that the average number of customers waiting for service, LQ, is equivalent to 0.0676 customers. The fourth step is that average number of customers in the system, which is L equal to 0.6926 customers. Fifth step is that average time for a customer spent waiting for service, which is WQ. My answer will be 0.01352 hours. The last step is to find the average time a customer spent in the system. W equal to 0.13852 hours. In conclusion, by adding another consultant, the percentage that customers should wait for a service is dropped to 31.25%. Other than that, both the average number of customers waiting for a service as well as the average time a customer spent waiting for a service is reduced to 0.0676 customers and 0.1352 hours or 0.8112 minutes respectively. Thus, by having two consultants will make Ocala even better than having one consultant. G. Ocala software system estimate that the cost of paying a consultant is 9 ringgit per hour. The cost that a customer have to wait in the system waiting for a technical support is estimated to be 15 ringgit per hour. Do a comparison in cost of waiting line between hiring one or two consultants. Discuss your finding. Let's look into one consultant first. As we all know, the arrival rate lambda equal to 5 calls per hour, service rate mu equal to 8 calls per hour, customer waiting cost which is CW equal to 15 ringgit per hour, and the service cost CS is 9 ringgit per hour. For one consultant, the total cost will be 34 ringgit. For two consultants, the cost will be 28 ringgit and 39 cents. This shows the total cost for hiring one consultant is 34 ringgit, whereas the total cost for two consultants is 28 ringgit and 39 cents. It will be the best for Ocala software system to hire two consultants because it has lower operating costs than one consultant.
Next, I will explain about question 3. The question is, currently Marty's barbershop has 3 barbers. Customers have an arrival rate of 8 customers per hour, and haircuts are given with a service rate of 4 per hour. Marty noticed that every end of the month, the arrival of customers increased to 12 per hour, while the service haircuts is at the same rate. Assume that the service time follows an exponential probability distribution, and the arrival follow Poisson distribution. If Marty set a rule so that the average waiting time in line no more than 5 minutes, what can you suggest to him? Use QM from Windows and discuss every output you get. This is solution for question 3A. As we can see, the arrival rate is 8 customers per hour, the service rate is 4 customers per hour, 3 barbers as the number of server, and the average time we can get from the QM from Windows is 6.67 minutes, which is it exceeds the rule that's set by Marty, which is supposed to be less than 5 minutes. So we take a conclusion to change the number of server from 3 to 4 number of server. Next, if we change the number of server from 3 barbers to 4 barbers, we can get the average time in the queue is 1.3 minutes, which is not exceed the rule that's set by Marty. So to achieve his rule, Marty need to change the number of server from 3 servers to 4 servers. So based on the question, Marty noticed that every end of the month, the arrival rate will be increased to 12 customers per hour. If we use the same service rate, which is 4 customers per hour, and 4 barber as the number of server, the time average in the queue is 7.64 minutes, which is still exceed the rule that is set by Marty, which is must be less than 5 minutes. So we need to change the number of server to 5 barbers. Next, if we change the number of servers to the 5 barbers with the same arrival rate and same service rate, the average time in the queue is 1.77 minutes based on the QM from Windows, which is not exceed the rule that's set by Marty. And to achieve his rule, Marty need to change the number of servers from 4 to 5 servers every end of the month. So the conclusion for question 3A, Marty should hire another barber to make the total of his barber is 4 barber on the normal day, and he should hire a part-time worker to help him on every end of the month to meet his rule that's set by himself. Question 3B, Marty estimate that he lost about 15 ringgit per hour of customer time spent waiting for the barber, and the barber is paid 12 ringgit per hour. Marty stand with his rule that the average waiting time in line not more than 5 minutes. Use the same number of barber hired in answering A, then make a comparison. Give your recommendation. This is the solution for question 3B. If the arrival rate is 8 customers and service rate is 4 customers, the cost of waiting is due to the time spent in the system. If the number of servers is 3, the total cost is Rm 79.33 ringgit. The cost of waiting in the queue to time spent waiting in the queue, the number of servers is 3, the total cost is 49.33 ringgit. The cost of waiting is due to the time spent in the system. If the number of server is 4, the total cost is 80 ringgit and 61 cent. The cost of waiting is due to the time spent waiting in the queue. Number of server is 4, total cost is 50 ringgit and 61 cent. Marty should proceed with the higher 3 barbers on normal day as it promotes the lower cost compared to 4 barbers. Next, if the arrival rate is 12 customer per hour and the service rate is 4 customer per hour, the cost of waiting is due to the time spent in the system. Number of server is 4. Total cost is RM 150 ringgit and 92 cent. The cost of waiting is due to time spent in waiting in the queue. Number of server is 4. Total cost is RM 70 ringgit and 92 cent. The cost of waiting is due to the time spent in the system. Number of server is 5. Total cost is RM 110 and 31 cent. The cost of waiting is due to the time spent waiting in the queue. Number of server is 5. Total cost is RM 65 ringgit and 31 cent. So, Marty should hire 5 barber on the end of the month as it promotes the lower cost compared to the 4 barbers. Conclusion for question 3B, Marty should make sure to choose the most minimized cost in operating the queuing system. For the normal day operation, he should proceed with 3 barbers as the server as it promotes lower operating costs compared to 4 barbers. And for the end of the month operation, he should proceed with 5 barbers as the server as it promotes lower operating costs compared to 4 barbers.
Next, question 4. Matic's fast food franchise is considering operating a drive-up window food service operation. Assume that customer arrivals follow a horizontal probability distribution with an arrival rate of 24 cars per hour and that service times follow an exponential probability distribution. Arriving customers place orders at an intercom station at the back of the parking lot and then drive to the service window to pay and receive their orders. The following 3 service alternatives are being considered. First, a single channel operation in which one employee fills the order and takes the money from the customer. The average service time for this alternative is 2 minutes. Second, a single channel operation in which one employee fills the order while a second employee takes the money from the customer. The average service time for this alternative is 1.25 minutes. And the third alternative is a 2-channel operation with 2 service windows and 2 employees. The employee stationed at each window fills the order and takes the money from customer arriving at the window. The average service time for this alternative is 2 minutes for each channel. For all options, answer the following questions. A. What is the probability that no cars are in the system? B. What is the average number of cars waiting for service? C. What is the average number of cars in the system? D. What is the average time a car waits for service? E. What is the average time in the system? F. What is the probability that an arriving car will have to wait for service? And the G question is, customer waiting time is valued at RM25 per hour to reflect the fact that waiting time is costly to the fast food business, and the cost of each employee is RM650 per hour. What is the lowest cost design for the Matic's fast food business? For the first alternative, a single channel operation in which one employee fills the order and takes the money from the customer. The average service time for this alternative is 2 minutes. The arrival rate, which is lambda, is 24 cars per hour, and the service rate, which is mu, is 1 car per 2 minutes. As the lambda in hours operation, we need to find how much car in an hour for mu. So, we need to divide 60 minutes by 2 minutes. Then, we will get 30 cars per hour for mu. For the A question, we are required to find what is the probability that no cars are in the system. In order to find it, we will use the P-now formula. In order to use the formula, first we need to find the rho. Rho formula is lambda over mu. Then, we will get the rho is 0.8. After that, we can find the P-now, which is the formula is 1 minus rho. Then the last answer, which is the probability that no cars are in the system, is 0.2. Next, the B question. What is the average number of cars waiting for service? For this question, we need to find the LQ. Based on the table from the QM for Windows, the LQ is 3.2 cars. Besides, question C, what is the average number of cars in the system? This question requires us to find the L, which is equal to 4 cars. Next, the D question. What is the average time a car waits for service? For this question, we need to find the WQ. Based on the table from the QM for Windows, the WQ is 0.13 hours. Moreover, question E, what is the average time in the system? This question requires us to find the W, which is equal to 0.17 hours. And for the F question, what is the probability that an arriving car will have to wait for service? The answer is 0.8, which is get by using the formula rho. Last but not least, for the first alternative, G question is, customer waiting line is valued at RM25 per hour to reflect the fact that waiting time is costly to the fast food business and the cost of each employee is RM650 per hour. Then, by the information given, the cost of waiting due to the time spent in the system is TC equal to RM106.50. Additionally, the cost of waiting is due to time spent waiting in the queue is RM66.50.
The arrival rate, which is lambda, is 24 cars per hour, same as the first alternative. And the service rate, which is mu, is 1 car per 1.25 minutes. As the lambda in our operation, we need to find how much car in an hour for mu. So we need to divide 60 minutes by 1.25 minutes. Then we will get 48 cars per hour for mu. Then, for the second alternative, a single channel operation in which one employee fills the order while a second employee takes the money from the customer. The average service time for this alternative is 1.25 minutes. For the A question, we are required to find what is the probability that no cars are in the system. In order to find it, we will use the P-null formula. In order to use the formula, first we need to find the rho. Rho formula is lambda over mu. Then we will get the rho is 0.5. After that, we can find the P-null, which is formula is 1 minus rho. Then the last answer, which is the probability that no cars are in the system, is 0.5. Next, the B question. What is the average number of cars waiting for service? For this question, we need to find the LQ. Based on the table from the QM for Windows, the LQ is 0.5 cars. Besides, question C. What is the average number of cars in the system? This question required us to find the L, which is equal to 1 cars. Next, the D question. What is the average time a car waits for service? For this question, we need to find the WQ. Based on the table from the QM for Windows, the WQ is 0.02 hours. Moreover, the question E, what is the average time in the system? This question required us to find the W, which is equal to 0.04 hours. And for the F question, what is the probability that an arriving car will have to wait for service? The answer is 0.5, which is the answer by using the formula rho. Last but not least, for the second alternative, J question is, customer waiting line is valued at Rm25 per hour to reflect the fact that waiting time is costly to the fast food business, and the cost of each employee is Rm6.50 per hour. Then, by the information given and the table from the QM for Windows, the cost of waiting due to the time spent in the system is TC equal to Rm31.50, and the cost of waiting is due to time spent waiting in the queue is Rm19. Then, for the last alternative, which is the third alternative, a two-channel operation with two service windows and two employees. The employee stationed at each window fills the order and takes the money from customers arriving at the window. The average service time for this alternative is 2 minutes for each channel. As the question stated, this alternative is a multi-channel system. For the A question, we are required to find what is the probability that no cars are in the system. In order to find it, we will use the P-null formula. The formula used is as shown in the slide. After we fill in the formula with the information given in the question, we will get that the probability is 0.4286 as in the table of QM for Windows. Next, the B question. What is the average number of cars waiting for service? For this question, we need to find the LQ. Based on the table from the QM for Windows, the LQ is 0.15 cars. Besides, question C, what is the average number of cars in the system? This question required us to find the L, which is equal to 0.95 cars. Next, the D question, what is the average time a car waits for service? For this question, we need to find the WQ. Based on the table from the QM for Windows, the WQ is 0.01 hours. Moreover, the question E, what is the average time in the system? This question required us to find the W, which is equal to 0.04 hours. And for the F question, what is the probability that an arriving car will have to wait for service? The answer is 0.4, which is the answer get by using the formula rho, which is lambda divided by the S times mu. Last but not least, for the third alternative, G question is, customer waiting line is valued at Rm25 per hour to reflect the fact that waiting time is costly to the fast food business, and the cost of each employee is Rm6.50 per hour. Then, by the information given and the table from the QM for Windows, the cost of waiting due to time spent in the system is equal to Rm36.81, and the cost of waiting is due to the time spent waiting in the queue is 16 ringgit and 81 cents. After all of that calculation of the three alternatives, we are required to find what is the lowest cost design for Matic's fast food business. Based on the result that we get from the alternative 1, alternative 2, and alternative 3, the lowest cost design for the Matic's fast food business is alternative 2. If the cost of waiting is due to time spent in the system, which are only Rm21 ringgit and 50 cents, as it promotes the lowest cost compared to alternative 1 and alternative 3. But if the cost of waiting is due to the time spent waiting in the queue, Matic should choose alternative 3, which are only 60 ringgit and 81 cents, as it promotes the lowest cost compared to alternative 1 and alternative 2.
So that's all from us.
Thank you for watching.
Bye.
Bye!